Dear friends, in this video, I'm going to discuss the graphical method for the very same example that is part of what we call a journey in linear programming, LP part 3. This is a good idea to get insights in the initial stages to understand the nuances of linear programming. The graphical method helps a lot. So let me proceed with the problem that is on hand. Graphical method formulation, the very same example which we discussed in part 1 and part 2, part 1 and part 2. And we are in part 3 to discuss the graphical method. So maximize the objective function or goal, maximize is z is equal to 15x1 plus 21x2 subject to the constraint x1 less than or equal to 4, 2x1 plus 3x2 less than or equal to 18, x1 plus x2 less than or equal to 8, and x1 and x2 are greater than or equal to 0, the non-negativity constraint that is always integral part of linear programming. So first thing we do is to draw the lines in the x1, x2 plane. So the line 1 is drawn, which is constraint 1 as a line is drawn. x1 is equal to 4. We have taken suitable scales, and this is the coordinate 4, 0, and x1 is equal to 4 is the line that is drawn, which is parallel to the x2 axis. x1 is equal to 4. This is the first line we draw for the constraint 1. Of course, it is less than or equal to 4, but first we draw x1 is equal to 4, the line. Then the second constraint, 2x1 plus 3x2 is equal to 18. So what we do is a trick. Put x2 is equal to 0, 2x1 is equal to 18, and therefore x1 is equal to 9. And this is 9, 0. So this line is drawn, which is 2x1 plus 3x2. And this part, when you put x1 is equal to 0, x2 is equal to 0, 6, which is written here. x2 will become 0, and therefore this part is 0, 6. So constraint 2, line drawn. Then constraint 3, x1 plus x2 less than or equal to 8. Therefore, we should draw the line x1 plus x2 is equal to 8. When I put x2 is equal to 0, x1 is equal to 8. When I put x1 is equal to 0, x2 is equal to 8. So 0, 8, 8, 0, they are connected and the line is drawn here. Then we show all the three constraints in the same graph. 2x1 plus x2, for example, constraint 2 is equal to 8, 18. x1 is equal to 4 is here. 2x1 plus 3x2 is equal to 18 is here. And x1 plus x2 is equal to 8 is here. Then we should have the condition that should be satisfied. x1 must be less than or equal to 4 is this side. 2x1 plus 3x2 less than or equal to 18 is this much side. This can go up to this, but this is less than or equal to 18. And x1 plus x2 less than or equal to 8 is here. So all the three constraints are satisfied in the quadrilateral ABCD, and therefore the four lines are drawn with a thick format to understand, and this is the feasibility region 0, 6, 4, 0, 0, 0, and this part is 4, 3 and 1/3 because x1 is equal to 4, and 2x1 plus 3x2 is equal to 18. We solve, substitute x1 is equal to 4. We get 3x2 is equal to 10, x2 is equal to 3 and 1/3. So x1 is equal to 4. Therefore, this coordinate 4, 3 and 1/3, 3 and 1/3. This is 0, 6. This is 4, 0. This is vertex D 0, 0. So A vertex 0, 6. B vertex 4, 3 and 1/3. C vertex 4, 0 and coordinate D 0, 0. Therefore, the feasibility region is inside, and in any point in the feasibility region will be a solution to the linear programming. But what is the optimum solution? In linear programming problem, the optimum solution when it exists is always one of the corner points in the feasibility region. Select that corner point which gives the maximum Z value, which we can see. In other words, go back to the previous slide. Take this corner point A 0, 6, substitute in the objective function Z is equal to 15x1 plus 21x2, you get 126. The corner point B, which is there, let's put 4 and 3 and 1/3. When I substitute, you get 130. The corner point C, which is 4, 0, when we substitute in the Z function, it is 60. The corner point D, for example, is 0, 0. So when I substitute, it is 0. And therefore, the solution is one of the corner points, linear programming theory, which is the optimum solution. The optimum solution is always one of the corner points. There could be multiple optimum solutions in some cases, but the Z value will not change, but it will be given by the corner point. And let's look at it. This is 126. A coordinate, B is 130. At C, the solution is 60. At D, it is 0, 0. The value is 0. Therefore, I have marked it here with the green color shade. 130 is the optimum solution, which says Z is equal to 4. X1 is equal to 4. X2 is equal to 3 and 1/3. And the value of Z that is maximized is 130. And therefore, this is the solution to the linear programming problem. All the 4 constraints are satisfied and we have solved the problem. Thank you very much. We will see you in the next video soon. Thanks a lot.